Hi Math 1 students. Today we're talking about 611 Day 3 notes. We are using coordinates to prove geometric theorems with slope and distance. So if you look at number 1, it says determine if the 4 points given constitutes a rectangle. A rectangle is a four-sided figure with 4 right angles. Use the slopes to justify your answer. So I have graphed A, B, C, and D. And so it says we are trying to prove that this is a rectangle. If rectangles have 4 right angles, then we're essentially looking for perpendicular lines. So it says start by calculating the slopes of each segment. If consecutive sides, so sides that touch one another, are perpendicular, then a right angle is formed. So we are looking for 4 right angles. So I calculated the slope of AB by using the slope formula. And so once you simplify that, you would get that the slope of AB is 0. For BC, the slope, do you notice how 0, it was 2 divided by 0 when we did the slope? So that would be undefined. And then CD, 0 divided by 2, so that was 0. And then DA was undefined. So we're looking for we're looking for perpendicular sides to give us those 4 right angles. So if you look from 0 to undefined, do you notice how when it's a slope of 0, it's a horizontal line? And when it's undefined, it's a vertical line. So those two will form a right angle. So this AB to BC, those two lines are perpendicular to one another. And then since this goes from undefined to 0, this is perpendicular. And here this goes from undefined to 0. So these two consecutive sides are perpendicular. So on this one, we have proven, because undefined and 0 slopes are perpendicular to each other, we have proven that it is a rectangle because it has 4 right angles. Okay, so we can conclude, yes, a rectangle, because there are 4 right angles. Okay. You are going to do one of these problems on your own. Make sure that you show the work. All right, so if we look at the next one, it says determine if the points form a parallelogram. A parallelogram is a 4-sided figure with opposite sides parallel. Use the slopes to justify your answers. So since we're looking for opposite sides parallel, we are looking for the opposite sides to have the same slope. So I calculated the slope of all sides. So AB was negative 2/3. The one across from it was positive 2/3. So are those sides parallel? Well, one's negative, one's positive. That's not the exact same slope. So these two are not parallel. So I'm going to now look at the other opposite pair of sides that I have. So we said the slope for BD was undefined. The slope of AC was also undefined. If you look, it's a vertical line, so we could have just looked at it and said it was undefined. So since those are the exact same slope, these two are parallel. So does that mean that this figure is a parallelogram? We're going to say no. So is this figure a parallelogram? Well, we would say no, there is only one pair of parallel sides. We need both pairs of sides to be parallel in order to prove it's a parallelogram. You're going to try this one on your own. Make sure you show all of your work. All right, this last one says determine if the points form a square. A square is a four-sided figure with two pairs of parallel, that needs the word sides, and then consecutive sides that are perpendicular, and then all sides are congruent, meaning that they have the same length. So we're going to use the slope formula to determine parallel and perpendicular, and then the distance formula to determine the length, if the sides have the same length, which means that they are congruent. So before we get started on that, remember the slope formula and distance formula have pieces that are very similar. If you look in the numerator, it's y2 minus y1 for the slope, and that is my second component of the distance formula. In the denominator, you have x2 minus x1, and that's that first number inside of the parentheses in the distance formula. So we can actually use the slope formula to quickly calculate the distance. So if I look at this first problem, I'm going to do y2 minus y1, so that would give me 5 minus 2, and then we could say in the denominator I would have 1 y2 minus y1, so this would be 3, leave, change, over 2. Okay, so this number represented y2 minus y1, and this number represented x2 minus x1. So we can actually just transfer that quickly to my distance formula. So I know that the distance formula is the square root of x2 minus x1 squared. So I'm just going to take 2 and square it. y2 minus y1, so we'll just take 3 and square it. So 2 squared is 4, 3 squared is 9. So here I would get the square root of 13, which is approximately 3.6. All right, we have to do this 3 more times. So for BC, if I do the slope, I get 3 minus 5 over 4 minus 1. y2 minus y1 over x2 minus x1. So then here I would get negative 2 over 3. So I'm going to take these numbers and I'm going to substitute them into the distance formula. Remember, the denominator represents x2 minus x1, so I'm going to say 3 squared plus negative 2 squared. So I would get 3 squared is 9, negative 2 squared, make sure you put the parentheses around it, is 4. So here I get square root 13, which is approximately 3.6. Okay. So the slope, y2 minus y1, so I would say 0 minus 3 over 2 minus 4. So here I would get negative 3 over negative 2. So the slope here, a negative divided by a negative, would reduce to a positive 2/3. So before you reduce, because this represented y2 minus y1, and this represented x2 minus x1. So those are the numbers we're going to want to use for our distance formula. The numbers that we get before we simplify. So if I look here, I have the square root of negative 2 squared plus negative 3 squared. Well, negative 2 squared, so that would be 4. Negative 3 squared is 9. So here I get the square root of 13. So that is approximately 3.6. The last one, side DA. So that says we're going to do y2 minus y1, so 2 minus 0 over, and then x2 minus x1, so that would be negative 1 minus 2. So here I get 2 over negative 3. So I can take these numbers and plug it into my distance formula. So this would be negative 3 squared plus 2 squared, which is the square root of 9 plus 4, which is the square root of 13, which is approximately 3.6. So we have to check and make sure, is this a square or not? Well, are opposite sides parallel? So I'm checking to see is AB the same slope? Is AB the same slope as CD? Well, AB was 3/2, and so was CD. So yes, those are parallel, okay? So the slopes, so this was 3/2, this was 3/2. So yep, those are parallel. And then we can look at the other sides, and we would say BC and AD. What were those slopes? -2/3 and -2/3. Good, so those are also parallel. So we have the first requirement, that the opposite sides are parallel. So now we have to look for perpendicular. So if I go from AB, what's consecutive with AB? BC. So is this opposite sign reciprocal slope? Well, it flips and becomes its opposite sign, so that tells me that these are perpendicular. It goes from -2/3 to 3/2, so that would be perpendicular because it flipped and became the opposite sign. Same from here to here. It flipped and became its opposite sign. And if I go back up to the top, same thing happened here. So all sides are perpendicular, so that means that I have 4 right angles. So we have 2 of the 3 requirements. We have opposite sides parallel, and we have consecutive sides perpendicular. The last thing said, are all sides congruent, meaning that they have the same length. Well, if I look at the length of all of these, I got root 13, root 13, root 13, root 13. So those are all the same decimal, 3.6. So we have proven that this is a square. So we could say, yes, this is a square. Since opposite sides are parallel, consecutive sides are perpendicular, I'm just going to use the symbol for perpendicular, that upside down T, and all sides are congruent, meaning they have the same length. So the squares are the ones that are the most complicated because you have to check for 3 things. You have to check for opposite sides parallel, consecutive sides perpendicular, and all sides are congruent. So that requires you to find the slopes and the distance formula. You're going to do one of those on your own as well. Make sure you check Google Classroom.